improving.
Welcome back to day 19 of LeetCode grind. Solve or go home. 30 minutes solve or go home. Alright, let's see. Let's see what we got. Did you do this one already?
Maybe. What is it?
Oh, you didn't even look at it yet. Okay. That's a
I might have done it.
triangle. Okay. Given a triangle array, return the minimum path sum from top to bottom. Okay. For each step, you may move to an adjacent number of the row below. More formally, for index I on the current row, you may move to either index I or index I plus 1 on the next row. Okay, so this is a 2, 3, 4, 6, 5, 7, 1, 4, 8. The minimum path sum from top is 2. Okay, so so you want the minimum sum at the end, basically. 2, 3, 5. Oh, it goes from top to bottom. Okay. So it says, wait, it says more formally on index I, you may move to either index I or index I plus 1. Why does it say it like that?
That makes sense.
Oh, I see. You can't go from like 3 to 7. You have to go from, it has to be a neighbor. I see, okay. I see, okay. So this is, if they want minimum, it's probably DP. Why is there so many DP questions? Sure. Why is everything DP nowadays? What the hell, man? It's so annoying. Okay,
That's fine.
Well, I think you can start your DP with the first element because you're forced to take it. There's no other way about it.
Right.
Okay, and then you check. Okay, so if I check the two right next to it, getting the minimum isn't necessarily the best because the bigger one could lead to a smaller path. So you have to check that path too. So if what you're memorizing is probably okay, so
well, hang on. Do we need DP?
I don't know. I just assume we need DP. We might not.
Oh well. Like
I think
you have to go through each level, right?
Yeah, because the reasoning I'm thinking you need DP is because if the triangle index is super long, you have to look at so many paths. So if you don't have DP, you're going to be running the same. You might be running the same paths over and over again.
Kind of. But DP, you still have to process it anyway. So, okay, but you're doing a level by level, right? So
yeah.
Why can't you do BFS?
BFS. Well, BFS works, but then BFS, how are you tracking the minimum path? Oh, are you just like have a min bar and then you just no, that doesn't work because if you grab the next minimum, you might not go to a good path. It might be a bad path. So how do you know? How do you know that that choice was a good choice, basically?
Oh, you only care after you reach the end.
Yeah, but let's say you kept you're optimizing, right? But then like you might have chose the wrong choice and you get to the end. How do you know that that was the right choice? Like when do you have to go backwards and do it again?
It's minimum. No, it's the minimum when you reach the end.
Yes, but that means you have to do the BFS on everything.
Okay.
Right?
If you don't do that, then how are you gonna find out?
So you do have to do everything, regardless.
Right. But what if you have numbers and then the last row is all like minus 100 or something, right? Like you don't know.
Yeah, so you do have to do everything. Okay. So if you are doing everything and you're doing BFS, you look at the left, you look at the right, you put them into the stack, and then you just track your current minimum as you go. Is that doable? So yeah, okay, so I start with the first element and then I put into frontier, and I pop it. Grab the two neighbors, 3 and 4. Look at those. Current path is either 5 or 6 at this point, and then I pop those. Well, I pop 3 first, let's say, and then if I push it into the stack, into 3, 4. So I'm going to pop it 4 first. So when I pop 4, it's going to look at 5 and 7, and then it's going to put those into the stack. So you got 2, 4, and 5, or 2, and no, you're going to pop 7 first. So it's going to be 2, 4, 7, and then the children of 7 is 8 and 3. You can pop 3. So you're going to get the first BFS pass throughs, and you get 2, 4, 7, 3. So you track that, and then you pop the 8 next, and then you'll have 2, 4, 7, 8, and then you'll check that, and then if that's the min, you replace it. Otherwise, you don't. And then it will pop 5 next, I think, and then it will be 2, 4, 5, and then you put in 8 and 1, and then you do 8. Okay, this would do all the paths. I think that if you do a stack with BFS, you will get all the paths, and you just have the running total, and you just min it out each time. Just call min on your current total. Is that too much runtime?
I don't know. Try it.
Okay. All right. So current algo, we're gonna do a BFS with stack. I guess BFS is always stack or whatever. Okay. Triangle 0. It's guaranteed to be 1 element. Wait, do they ever pass you an empty one? No, it has to be at least 1 left. Okay, we're fine. So this one's guaranteed to work. Okay. While frontier element equals frontier.pop. Okay. This should be a list, because it's going to be a list later on. Okay, and then for I in list, frontier dot append element. Okay, so in this case, it's 2. Wait, no, it's not elements. You gotta get the children. So this is wrong. How do we get the children? The structure isn't a children. The structure is just a list of a list. Okay, so basically it's just levels. So I put in 2. Okay, so wait, that's weird. So would I have to build kind of a children structure for this? Or, oh no, if I just store a tuple of the level you're on, you just grab the level below it. But then how do you know which ones are the left and right child? Because it's not everything on that level is your child. So you have to store your level and the index. Okay. So this case would be if I'm storing triangle 0. Okay. Oh, wait. Okay, so I don't need to put in the actual triangle element, because we're just pulling that from the triangle. So we just need a tuple of the level, which is level 0, and then this is index 0. And then that should be fine, because this is index 1. Index 1 means you can either hit index 0. No, this is index 0. Index 0 means you can hit index 0 or index 1. Index 1 means you can hit 1 or 2. Okay. And 0, 0, 1. 1 is 1, 2. And 2 is 2, 3. Okay. That should work. Okay. So I pop the elements. This is XY. Okay, so that tuple is let's call it better stuff. Call it level and index. Okay, so that is what I have. Then I will check the neighbor. I will pop the neighbors. I will append the neighbors to the frontier. Okay, so frontier. Okay, so it is frontier. Append. You want level plus 1 and index, and also frontier append level plus 1 and index plus 1. Okay, I think, wait, so if I have these appended into my frontier, okay, yeah, and then I pop, yeah, I'm always popping the one before the last one, so that's fine. So in this case, I have two, I popped out 0, 0, and then I'm appending level 1 index 0 and level 1 index 1. Yes, okay, and then when I pop it, okay, so when I pop it, I also need to grab the value. So value equals triangle, and it will be level index. That's the current value, and then I need I need a running total of this value. Okay, wait, so yeah, I also need a check if I'm on the last level. That means I want to store it. I need to check it. Okay, so last level equals triangle, len triangle, I believe is what it is. Yeah, length of this is 4, so that means last level is 4, like it's 3 minus 1. Okay, so when I pop it out, I store the value. No, I should just append it to the running total. Okay, when does the running total reset? When I hit the last level, I need to reset it. But then, oh wait, no, that doesn't work, because if I reset it, I won't have track of everything on the way down. 2, 4, 7, 3. If I get this one first, and then I do 2, 4, 7, 8. If I reset it, then I've lost 2, 4, and 7. Oh, okay. Instead of resetting it, I just subtract out the previous one, add the current one, and see if it's a better one. Otherwise, don't do it. So how do that means then you store the previous add on last level? Wait, actually no, that doesn't work, because if I do 2, 3, 6, 4, this stuff isn't on the same path. It's a totally different path. How do I store this? What am I storing? Oh wait, I can wait, no. Maybe the tuple needs another one with the sum, maybe? Yes? No, I don't think so. Wait. So there's no 1, 0, 1, 1. 4. Yeah, if I store the total sum as I go down, it should be fine. Yeah, because then I just pull. That means each index, I would have the total sum. Yeah, I think that's fine. Okay, I think I do store it then. Let's call it rect equals integer float. Okay, and then the value I pop out is here. So yeah, I need to put a running total here. So okay, so if I'm popping out, okay, I pop out the level and index and total. Total plus equals triangle level index. And then I put in total here. Okay, and then so when so if I do this and then I go to the next loop, I pop out 4 here. 4, I get level 1, index 1, and running total of 2. Okay, and then I append 4 to it. So that would be 6, and I don't store it back, but that's 6. Oh, and I do need to update it, but it's popped it. Wait. No, that's fine. 6 is here. So I send 6 to the next ones. Yeah, that's fine. Yeah, that's totally fine. Okay. So I have 6 at this point, and then I'm appending the children of 4, which is 5 and 7. So me popping 7 out. 7 comes out level 2, index 2. Total is 6. And I add 7 to it. And I put it back. Okay, I think that does do the job. Okay, so after all this, when I hit the last level, I do a check. Okay, if last level, oh, okay, wait, yeah, I only append if it's not last level. So if not last level, if level plus 1 greater than, wait, just do equals, yeah, equals last level. This is the else. Okay, that's fine. If it's last level, ret equals min of ret and total. Yeah, otherwise do this stuff, and then this stack will preserve the things and it should be fine. Do some prints maybe, see what's going on. Yeah, let's see. That actually matches up already to a -10. I don't know if I checked this edge case. I think it's fine though. Yeah. Alright, let me try a crazy one. Let's put in some extra stuff here. Oh, oops. It needs to be 5 elements. Let's do 0. Oh, look, it worked. It worked. Oh no. Time limit exception? Shit. Alright, how do I optimize this? That's a long ass input. Super long input. Alright, Al, any thoughts?
I think you might be right with the EP thing.
It has to be DP.
Not necessarily. Or you can build it as you go. You don't have to do BFS.
What do you mean by build it as I go?
Let's see. What is this? That's my weird hook here.
Do you just do a DP on each level, and then the running total on each level? That's all you have to track.
Do we need to do that? Sometimes I'm weird.
But why? Like you said, you have to go through every index, right? So why is this?
Right.
Why is this taking extra runtime? It doesn't make sense. Did I mess up somewhere?
I don't think so.
It looks like the flow is correct. I'm not visiting the nodes again. It's just each node based on the stack, right? Yeah, I don't see why. Let me print this. Oh, there was a shitload of stuff, so it's probably gonna print way too much stuff. Maybe there's like a math shortcut or something. I don't know if it's actually DP, maybe just a math thing.
I think you can just write it every time.
Is there like a greedy approach to this? You can't really greedy it. Do we need the WLANs?
Oh no. Yeah, I should have worked on this earlier. I'm just thinking about it in real time. So
Okay, that's fine.
I mean, I think DP is right.
But like, what are you memoizing? What allows this to work? Oh, wait. If you, no.
Okay, so let's say you start at the bottom, right?
Sure.
And you know the running total of what the sum is up to that point.
Oh, how do you know that if you're starting at the bottom?
Oh, so at the bottom, well, first of all, your total array is at most the length of your bottom one, right?
Your total array is at most the bottom one? How is that possible? Don't you have to add everything on the way to there?
Well, sure. But
What do
you're
you mean?
starting with one of those elements.
Sure, okay.
So now for each of these indices, you're starting with the bottom guy, right?
Okay.
Okay, and then when you move one level up,
Sure.
then you're basically going to, for each index, add the minimum of the value to the left or the value to the right.
Yeah.
Right?
Mm-hmm.
So when you do all of this, you're gonna have the full array of minimums. Then you just return the smallest value there. So the reason why this is fast is because you process each element once and you don't have to do the Q, DQ.
Wait, can you explain that again? So we're starting at the bottom,
Right,
right?
let's say you have the example, right?
Yeah. Okay.
What's an example?
4183.
Right. So we know that there's going to be a DP array of 4 indices,
Sure. Okay.
and it's going to be 4183. And then for position 4, you know that it has to add the minimum of something that it cannot reach on the left, or something that it can reach, which is 6 on the right. So the minimum for the first index at the second layer is 10. And then the minimum for 1 is the minimum between 6 and 5, right? So you're going to add 5.
Okay. Oh, I see what
And
you're
the
doing.
minimum
Okay.
5 and 7, and you're going to add 5.
Yeah, I understand that. So you're saying this is faster because you don't need a pop?
Right. You just are changing the index. You're making one array and then you're incrementing index.
Yeah, so your array is just the length of the last level, basically. And then you're just moving upward, taking the minimum as you go.
Right. And
Isn't
then
that
you
the same
know that.
runtime, though? Why is that faster?
Well, you do one operation. You're checking left and right.
You're just adding. You don't need a pop. You don't need a append. So a popping and appending is just costing too much right now.
I guess so.
Those are all of ones, though. All right, I can't. I mean, I think I know what you're talking about. I can code this up, so I'll try it out, I guess. All right, so I initialize my memo as for I in triangle 0. Oh wait, no, not 0. Len triangle minus 1. Yeah, so that's the last index. Actually, just do -1. What am I doing? -1. That will get me the last.
You can start with -1, yeah.
So that would be the last one for I in triangle. Okay, that should get me the array, right? I don't know if that's the correct syntax, but let me try it out. Okay, that's not correct syntax. What's wrong here? Alan? What's wrong with the syntax?
What?
What's wrong with the syntax? I said memo equals bracket for I in triangle -1.
You didn't do anything on the left.
What do you mean by the left?
You need something for I in, so probably I for I.
Oh, does that mean I would just put in the element into it?
Right. I mean, you can also just type, say it's triangle -1.
Oh, really? Literally? Oh yeah. I mean, yeah. Actually, that it is an array already, so I don't know why I even bothered. Okay, my bad. That should be good. Okay, I have the last one. Okay, and then now I traverse upward. So yeah. So okay. Given the okay, so index 0 should be getting from index 0 only, right? The only neighbor of index 0 is 0. So memo, okay, okay, how am I looping this? I'm looping for the number of levels. Is that what it's doing? Okay, so if I check 4, you go to 6, then you go to 3 and 2. So that's three loop. But if I go from 1, yeah, 1 I check the minimum of 6 and 5. Oh yeah, I only do, yeah, so it should be a loop of len triangle -1.
Okay.
Yeah, okay, so that's 3. Okay, so now I need to say, given my current index in the memo, oh wait, so I need to loop through all the index in the memo. So for okay, I'll just do memo index equals the min of memo index plus triangle. Okay, I need to do this in reverse. I need to do this looping in reverse. Okay. Triangle curl level and also index, and then I need to check index plus. Wait, no, index is index and index -1. But then if it's out of bounds, don't check it. Yes, because 1 is index 1, so when you check index 0 and index 1, yeah, so it should be -1. Okay, so I need to do okay, so I need an if statement if it's out of bounds. If index -1 less than 0, less than 0. Oh, I can actually do this outside of the min. Yes, that's fine. Okay, yeah. So then, yeah, if index minus 1 is less than 0, then I only do this, else I'd get both children. Wait, actually no, 3 only has 1 children, 2, it can't access 5. Okay, so minus 1 less than 0 doesn't work for this. Wait, actually no, wait. If I'm 3, that's index 3? So it checks index 3 of the previous. Oh, okay, so I need that case too. So also elif, so or index is greater than length of triangle curve level. Length of this, yeah. So current level's length is 3. It should be equals. Because in 3, index 3, and then the length of the current level is 3. That means you can only grab. Oh wait, no. Yeah, so no, you can't do it or here. You have to do it elif. Okay, that's fine. Kill this. Elif. The memo index. Memo index. Triangle current level. Index minus 1. Yeah, I think that's fine. 2, if it's index 2, it's not equal to the length, so it's gonna get 5 and 7. Yeah, because index 2, yeah, it gets 2, which is fine. Yeah, that works. If it's 1, it gets index 1 and 0. That's also fine. Okay, and then I go up a level afterwards, and then I have the memo tracked here at this point. So let me print the memo and see what's going on at each level, and then basically return memo -1. Wait, is it memo -1? No, return the minimum of the memos. Is there like a Python min of an array? Can you just do this? Did you say something? I missed it.
Min works.
Okay. Let me run this, see if this works. Okay, index out of range. Something messed up here. List index out of range for this one. Memo index equals memo index plus. What's up here? How did this? Current level greater equals 1. Enumerates. What's ups? Alright, let me print this and see what happened here. 0 and 15. Why is index 15? Did I flip it around? Wait, what? How's this 15? What the hell? Oh, 15 is the element. Wait, is that how it works? So it's index comma element? Does that work? Oh, there we go. It's better now. Okay, so 0, 15. Okay, so something's still out of bounds. Okay. Which one is this one? What's out of bounds on which level? This level? 334. But how did I get two negative 191s here? Oh wait, no, that's... I'm doing something wrong here. Okay, so this is the memo at level 1, which is correct. And go up. It looks like it added itself, which is wrong. So something broken there. Level. Why is that? What's current? Current level is -1. Oh, did I? Is this supposed to be -2? Length of triangle is 4. Oh, right. This is supposed to be -2. I'm doing the wrong thing. Okay, it's still out of bounds, but it looks more correct now. Okay, what is causing this out of bounds? What edge case did I not check for this? Okay, so I pull out 19. This is fine, right? All the way to print all this. What's wrong? What is wrong? This two cases should have covered the two edge cases. This one should be fine. What's wrong with it? This index out of range. Okay, I guess I'll just print it then. What is the out of range? Oh, let's print the triangle. Current level 2. See what's up at here.
Uh,
657. Okay, so 657, 1 and 0. 1 is index 1 and 0. Okay. No, these are all within bounds. Wait, no. What the hell is 4, 3? I get to 4, 3. Should be 2, 2. Wait. Or 3. How did that happen? For index and element and enumerate. What is 657? What? That makes no sense. I need more. Okay. So.
Well, okay. I think you're getting stuck in the syntax, which you don't need to be.
What do you mean?
Okay, so let's look at the example again.
Sure.
So, I don't know if my stream is lagging or
I scrolled up. It's probably lagging. I'm
Right.
at the example.
So you see the 4183 at the bottom, right?
Yeah.
When you process 657,
Yep.
then you actually lose a digit as you go. So,
Uh-huh.
right. So at position 6, you're like, oh, below me there's 4 or a 1.
Mm-hmm.
And so obviously I should choose 1. At position 5, you'll be like, is it 1 or 8? I'm gonna choose 1. And at position 7, is it 8 or 3? I'm gonna choose 3. Right.
Okay.
So your array now updates to 7, 6, and 10. Right. And then on the next one up above that, you're gonna be 3, and then it's gonna be again, you're checking the two
Wait,
places below.
so you're morphing the memo now?
I think so.
Is that better?
Because otherwise, if you don't do that, then you're gonna have all these stuff from before, and then when you do minimum, you're not gonna be able to tell. But basically, as you go up the triangle, eventually you reach one element, which is always at position 0, because the first row is position 0.
I mean, sure, but like, that isn't that algorithm even more complex?
Oh, it's the same algorithm. It's just how you express it.
How is it the same algorithm?
You start with 4183.
Yeah.
Or sorry, I guess you can start with 00000, right? And um, basically, or as you run each row from bottom up, you're taking the two below at the current index and the index plus 1. Then you're like, which one is lower? I'm gonna add to the minimum of that, and then update your current position.
Basically, you're just reinitiating the array at each level.
You're updating the array at each level.
Yeah, but okay, so if you start at last level 4183 and you move to 657, how do you discard one of them?
But you don't discard one of them. Basically, you only care about because eventually it collapses to the 0th element.
Yeah, but are you popping from the array, or are you just what are you doing here?
You're not popping, you're just overwriting the value at that.
Yeah, but there's only 3 indexes at 657, but there's 4 at
That's fine.
4183. Yeah,
So you only care about the 0th index when you finish everything.
why is that?
Because the top of the triangle only has one element, which is at index 0.
Yeah, but all of them can reach index 0.
Right. The whole point of DP is that you've chosen the best one so far.
Yes, but okay. So if you have 4183 and you look at 657, then you're only updating 3 of the memo items.
You're going to be updating memo 0, 1, and 2. And then the next one you're going to update memo 0 and 1. And then the last one you're only updating memo 0. And that's what you return.
And then that's guaranteed to work. Wait, why is that guaranteed to work?
Because your triangle always has the top row that's size 1.
Okay, if you move up from 4183 to 657, and you only update 0, 1, 2 instead, that means
it's at the last digit doesn't matter.
yeah. So you're saying the 3 slots up to the 7, so you have a 10 in the next 2. The 1 slots up to the 5, so you have a 6 at index 1, and the 1 slots up to the first index also, at the 0th index. So you have 7, 6, and 10.
Right, so you have 7, 6, 10, 3, right? Technically.
Yeah, but you don't care. Okay, I see what you're doing. So basically, you're climbing upward, but you're only updating for however many elements are in the current level.
Yes.
Okay.
You won't ever run into index errors because you already have everything allocated.
I don't even know why there's an index error. It seems like a super simple thing. But whatever. Yeah, so if I do that, I would have to modify a lot, I think.
Oh, but then it becomes really simple, right? You can just initialize the array to be longer than the last row, and then you just have to check the current index and the index plus one for each row.
Oh
And check
no,
the
but
minimum.
you can just you just initialize same as before, just the last row.
You can do that.
You move up, and then you only update the first three indexes based on. So you loop through the current row, and you just add the elements that you need, and then put them back in to the memo.
Right. And then return the 0th element at the end of everything.
Okay. I think that's doable. Do I have to rewrite all this crap?
But 5 lines.
Is it 5 lines though? Is it though? Okay. I have this. All right. Let me start rewriting from up afterwards here, so I don't have to. Why is it not doing it? No, it's that. Okay. Okay. So I have the memo. I still want current level. Equals length triangle. Minus 2. Current level. For I in triangle current level. Is it for range? Okay, so if I'm looping through 6, 5, 7, I'm checking to see which of 4 and 1 is smaller, and then I just add that and put it back into index 0. And if 5,
A range length, range of length of that.
yeah. I'm just making sure my algo is good. Okay. Yeah. So I am doing. Yeah, I want index. That's fine. Okay, so for I in range line triangle 0, current level. Okay, so memo I equals the minimum of memo I plus the minimum of triangle I and triangle I minus I plus 1. Yes.
Wait. No.
What do you mean no?
Right. Triangle should always be there because you're using that element.
No, this is not. This is wrong. It's the current level triangle. Shit.
Right. So swap memo with triangle, and that should be right, actually.
Wait, why would I swap memo? I think that's right. Isn't this right? So
Oh.
I'm updating the memo at the index that the triangles, or the memo. Yeah. So it looks at index 0. My memo at index 0 is 4. So I'm adding 4 to the minimum between. Oh no.
The problem with it is
Oh,
that
that's
you
why.
can
Okay, I should be adding 6 to the minimum of these two. So it shouldn't be memo I. It should be triangle.
Right, that's what I said.
Oh yeah. Okay. I couldn't visualize that until I looked at the code. So current level I plus the minimum of memo I and memo I plus 1. Okay, so current level I is 0, which is 6, and then memo I is 4 and memo I plus 1 is 1. If I do 5, that'll be index 1, and then memo I is 1 and memo I plus 1 is 8. Okay, I think this works. So then I'm setting it to this, okay, and then done with this. So cur level minus plus 1, and then just return memo 0. That should work. Okay, I can print the memo at each level to see what's going on. Yeah, that looks good. Alright, cool.
Right, so I guess the more standard approach would just be to initialize memo with zeros and then have it look through the whole triangle.
Oh, instead of doing a current level start?
Right.
Yeah, I could do that.
It's the same thing. It's the same process.
The memo equals 0 times when triangle -1. And then instead of this, you do a -1 instead.
So it's just length. Well, +1, right?
For what? Oh yeah, len +1. So this, yeah, I would get the current level, which is the last index. Yes.
And length of triangle -1 is just length of triangle also.
Yeah, that should also work, I think. Nope, some runtime stuff. Okay, current level is length of triangle -1. That's 4. Oh yeah, you have to -1. It's 2. Yeah, it's out of index. Yeah, okay, that works too. Okay. Any other thoughts?
Yeah, it's TP can be tricky, I guess.
For sure.
So I guess the similar substructure here is useful. You have to identify that, oh, you only care about current and next.
What do you mean by current and next?
For the triangle, for each position you only care about the current value and the next value.
Oh, I see. Okay, and you just build it up. This only works if you start from the bottom, right? You can't do this from the top.
There's probably a top-down approach as well. But
Probably easier bottom up.
I don't know. Bottom up is guaranteed to collapse to position 0. Up down, I think it's doable, but I don't think it, would be a little trickier.
Okay.
But you'd have to calculate the minimum of the final array or something.
Yeah.
That's fine. Alright, let me try that.
I mean, yeah, if you're running a minimum on an array, it's not that bad of a runtime.
Right. Okay, let me try that and see if that fits anywhere. Oh, yeah, that's a problem because wait, then you gotta do float infinites or something.
Oh yeah,
Otherwise,
because
you
you're
zero.
doing you're because then you start with yeah. Okay.
What?
Wait, do you need floor infinite? If you start at 2, then you're fine, right?
No, it's tricky.
Yeah, it seems way trickier than this. This is actually pretty straightforward once you realize what you need to do. It's understandable to most people, I think. If you tell them, oh yeah, basically what you're doing is just looking up. Well, you technically you are going from the bottom up, but you're going down kind of. You pull this level out and you just pull, get the two children and see what's best and put it back in.